Hello everyone. Today I would like to introduce a fascinating mathematical idea that has captivated mathematicians, scientists, artists, and philosophers for centuries: the golden ratio, often represented by the Greek letter phi. The golden ratio is approximately equal to 1.6180339887 and so on, an irrational number that continues infinitely without repeating. It arises when the two quantities are divided in such a way that the ratio of the whole to the larger part is the same as the ratio of the larger part to the smaller part. A plus b upon a is equal to a upon b is equal to phi. At first glance, this may seem like a simple mathematical relationship. However, its significance extends beyond the numbers. The golden ratio represents a unique form of balance, proportion, and self-similarity that appears throughout the nature and human creativity. One of the most remarkable aspects of golden ratio is its presence in the natural world. The arrangement of sunflower seeds, the spiral of pine cones, the pattern of hurricanes, the even the structure of galaxies often exhibit relationship closely connected to the phi. These patterns are not random. They emerge because they provide efficient ways for growth, packing, and organization. In mathematics, the golden ratio is deeply connected to the Fibonacci sequence, where each number is the sum of the previous two. As the sequence grows, the ratio between consecutive terms approaches phi. This connection links simple arithmetic to the complex natural patterns. The golden ratio has influenced art, architecture, design, and even natural patterns for centuries. More than just a mathematical number, it represents a remarkable balance between the simplicity and complexity, revealing how the same underlying principles can create beauty, efficiency, and harmony throughout the nature and human creativity. It reminds us that the mathematics is not only a tool for calculation but also a language that describes the hidden order of the universe. Fibonacci sequence begins with a surprisingly simple rule. Each term is created by adding the two previous terms. At first, this appears to be nothing more than a pattern of numbers, yet hidden within the sequence is one of the mathematics' most profound constants, the golden ratio. As number grows, the ratio between consecutive terms gradually converges towards a single value, phi, which is equal to 1.6180339888 and so on. This reveals an important idea. The golden ratio is not imposed on sequence, it naturally emerges from its process of growth. Now imagine a building squares whose side lengths follow the Fibonacci numbers, beginning with the 1 cross 1 squares and successively adding larger squares: 2 cross 2, 3 cross 3, 5 cross 5, 8 cross 8, and so on. We create an expanding geometrical structure. As more squares are added, the outer boundary increasingly approaches a golden rectangle, a rectangle whose length to width ratio equals to phi. What is remarkable is that every new square grows from the previous structure, just as each Fibonacci number grows from previous numbers. The geometry is therefore a visual representation of recursive growth, a pattern creating itself from its own history. When quarter circle arcs are drawn through these squares, a spiral emerges. This spiral symbolizes a deeper principle found throughout the nature: growth that preserves its own form while increasing in size. Each self-preserving growth appears in shells, flower arrangements, hurricanes, galaxies, and many biological structures. The deeper significance is not that nature is perfectly governed by the golden ratio, rather Fibonacci numbers and golden rectangles demonstrate how simple local rules can generate global order. From the basic act of addition emerges proportion, from proportion emerges geometry, from geometry emerges patterns that resembles the structure we observe in nature world. The Fibonacci sequence teaches us that complexity does not always require complexity at the beginning. Sometimes a simple rule repeated many times is enough to create forms that appears almost timeless. The golden rectangles is one of the most beautiful manifestation of this idea, a bridge connecting numbers geometry, growth, and harmony. Let's talk about patterns, spirals, and self-similarity in nature. In here, as more and more seeds are added, something remarkable begins to happen. No spiral is explicitly programmed or drawn. The plant simply places each new seeds at a fixed rotation of approximately 137.5 degree, known as golden angle, while gradually moving outwards from the center. From this simple rule, a highly organized pattern emerges. Curving spiral arms becomes visible in the both clockwise and anti-clockwise directions. Even though the plant never intentionally creates spirals, this is an example of emergent pattern, a complex structure arising from simple underlying process. If we carefully count these spirals, we often find pairs of 2134, 3455, 5589. These numbers belong to Fibonacci sequence, revealing a deep connection between growth, geometry, and number theory. The significance of this arrangement is not merely aesthetic. The plant faces a fundamental physical challenge: how to place the maximum number of seeds within the limited area. Simple angles such as 90 degree, 120 degree, or 180 degree would cause seeds to align repeatedly, creating gaps and wasted space. The golden angle avoids such alignments, distributing seeds as uniformly as possible and maximizing packing efficiency. At the even deeper level, this phenomenon is linked to a unique property of the golden ratio. Mathematicians describe it as a most irrational number, meaning it is the most difficult number to approximate using simple fractions. Because of this, repeated overlaps are delayed for as long as possible. Each new seed occupies a new position, producing an exceptionally uniform distribution across the growth surface. This reveals a profound principle found throughout the nature: order can emerge without central control. The sunflower does not calculate spirals, count Fibonacci numbers, or understand geometry. Yet by following a simple local rule, it naturally generates a global optimized structure. The visible spirals are therefore not the cause of the pattern, they are consequence of an underlying mathematical principle governing growth. The sunflower teaches us one of the nature's deepest lessons. Extraordinary complexity and beauty can emerge from remarkably simple rules. What appears to be aesthetic or artistic spiral is in reality mathematics organizing matter into one of the most efficient patterns possible. Now what is golden ratio say? The true importance of golden ratio is not that it equals 1.618 or that it appears in flowers, shells, or work of art. Its deeper significance is that it repeatedly emerges whenever the system grow, organize, optimize themselves. In mathematics, it arises naturally from the recurrence relation and growth processes. In geometry, it appears through self-similar structure that preserves their form across scales. In physics, it emerges in quasicrystals, critical phenomena, chaos, and dynamical systems, places where order and disorder coexist. In biology, it appears when living systems solve problems of efficient packing, resource distribution, and growth. A striking example is Penrose tiling, a pattern discovered by mathematician Roger Penrose. Using only a small set of tiles, it can cover an infinite surface without ever exactly repeating. The proportions of these tiles are governed by a golden ratio, demonstrating that the order does not require periodic repetition. This idea later becomes crucial in understanding quasicrystals. What makes the golden ratio remarkable is that it often appears at the boundary between the competing tendencies: repetition and novelty, stability and change, simplicity and complexity. It is not merely a geometrical proportion, it is a manifestation of how nature balances these opposing forces. More broadly, a golden ratio reminds us that some of the most intricate structure in the universe are not designed from above. They emerge from the simple rules acting repeatedly across many scales. This connection between local rules and global order is one of the central ideas of modern science, appearing in complex systems, network theory, biology, and theoretical physics. Perhaps this deepest interpretation of the golden ratio is that it represents a principle of organized growth. It is not simply a number found in nature. It is a mathematical signature that often appears when complexity emerges from the simplicity, when order arises without a blueprint, and when system evolves while preserving its underlying nature. Thank you.